Hello, this video is part 2 of LoRa training for stable diffusion. It focuses mainly on comparisons. So we previously saw how LoRa can be trained in a stable diffusion and how a larger dataset can perform better than a smaller dataset for a character training, especially for full body shots without resorting to inpainting. Now in this video I will display an example of LyCORIS training for the same person using a subset of the previous data, okay, using 38 images only, and compare it with standard LoRa over the same dataset. Compare the same model using regularization and without, using captions and without, and present a conclusion on LoRa. I'll be using this set of images, which are 38 images. Okay, all of them are of high quality and clear. So the sizes of these images are 512. Some of them are 512 and others are 512 by 768. Okay, so we will be using buckets for the training. Now, regarding the regularization set, I'll be using this regularization set. It's a regularization set generated by ChillOutMix. Now we go back to the training. The first thing that we will do is captioning. I'll use WD14 because it seems to work better with the ChillOutMix. Some will use blip for people, okay? It's most likely that blip will be more dominant in the upcoming releases of XL version of stable diffusion. We select it, then here we can remove the one girl, solo, so because these are common in all images, etc., but I will leave the standard captions and caption the images. And when we caption, it will run here and tell us that it's completed. So once it's done, we can go back to Dreambooth LoRa here. We could have loading of a configuration file, for example, so that we don't have to set the settings every time. So each time if you have a good settings, for example, you save them, and the next time you load them so that you don't have to repeat the same process. The source model I will use ChillOutMix so that I can compare with the previous model I made in the previous video. Okay, that's it. Now, regarding the choice of models, ChillOutMix is slightly outdated, or it has not been updated for quite some time. There are currently, for example, realistic vision. It was updated today, so it's possible to use this model. The purpose of this video is educational only. Okay, so we could use any model that we like. We could also check the character and see some of the checkpoints here. I tested, for example, Analog Madness. It actually produces good images for characters. We don't want version 2 because we want 1.5. Now we choose the image folder, the class folder, which is the regularization set. Then we name the model output. This is the name of the file. The name of the file is different. It's different than this is the name of the instance. So this is the name of the instance. I can remove 0.3, for example, just give it a casta, but just in case it exists in the model. I don't think it does. Now, after we're done, we go to the training parameter, double check them. I'll use batch size of 2 or just 1 if we have problems. Let's run it, for example, for 20 epochs. We use the learning rate, same learning rate. We can make it constant. So I leave everything like default. I just will set the network rank 128 by 32. Now in the sample config here, now we have to write the command that we want to display so we can compare between the epochs before we compare them on automatic 1111. By the way, we could also change the clip skip to 1. Okay, for example, even here in realistic vision, it tells us that it's recommended to use clip skip 1. In general, for realistic pictures, we use this setting. For anime, or we could use clip skip 2 or more actually. Okay. Now we press train. We come here, we see the settings. We can double check the settings once again in case we made any mistake. Okay. This is the number of the steps that we can train. We can continue the training afterwards if we feel that the results are not okay. We could also check the resolution. So let's check the initial results from the model folder. Now this is the sample folder. Now we come to see the files. We see that from the initial epoch it's learning. The second epoch is improving. Now this is a general description of the subject. So we did not include the hairstyle, etc. We clearly see that the features do exist. And it resembles the subject to a certain degree. If we improve the prompt, the results will be better. Now at epoch 6, Now this shared does not exist in the dataset. If we come back to the dataset, we can see that now this is our dataset once again. This type of shared does not exist in the dataset, so we can say that it is actually generalizing to an adequate level. Epoch 7, Epoch 8, now we can see that at Epoch 8 the image started shifting. It is showing like something like artifacts. These are called like artifacts. These artifacts increase with overfitting, and the facial features are not as good. So I think that by reaching to Epoch 7 we should stop training. So it's okay to go and stop the training now. Now in this test we will remove the classification images. So just remove this, and we will use the same settings that we used earlier before. So without regularization, the number of steps drops. Now, if we come and track the progress of the epochs, we can see that without regularization, so from the first epoch, it gives more resemblance than when we are using regularization. The second epoch actually looks good. Okay, and it's better than the second epoch compared to regularization. The third, however, is starting to change and starting to break. I'm not quite sure if this is good or not, but it does not. It looks like it's starting to break gradually, so we can stop training. Now, this test will check using LyCORIS instead of the standard LoRA and see how it's different from the standard LoRA. So LoRA, LyCO. Okay, we will use regularization in the first test for this one. Now, from here, from the LoRA type, we would choose LyCORIS, for example, convolutional. Now, convolutional neural networks in general are better at learning images and detecting patterns in these images. They are better than the standard neural networks used in the LoRA model, so it's expected that the convolutional will produce better results in general. Now, the settings are basically, I will keep the same settings basically. The only change that will happen here is that I will use different settings because convolutional neural networks, it's recommended to have something less than 64. Clip skip 1, the default settings, then we press train. Okay, so it tells us here that the same number of steps, 11,400 steps, because we are using regularization set. It will also say that we are using LoRa LyCORIS, LoCon, convolutional method. The transition between the epochs is much smoother in terms of loss. Now, when we come to the pictures, the initial pictures from the first epoch actually looks acceptable and better than the first epochs in the previous tests. The transition between the epochs actually looks very smooth. And it's almost similar to the target, but this is because of the prompting. You can see that the transition is much smoother, and it starts breaking almost at the final epoch, at the epoch 10. So we can say that approximately till epoch 8 it's acceptable. And no, we just changed the file name, no reg. Now, to run the model again without regularization, we can see that the number of steps will drop. So in this training set, I will be removing the captions, which is also acceptable because we are only training a single subject. Then we will go back to the settings. We will change no captions, no caption. Now we come to the model and copy the files for the LyCO. In the models folder, we would go to the LyCORIS and paste them here in this location. Go back to samples. We come back to stable diffusion. Now by default, LyCORIS is not installed. So down here, we will not see LyCORIS, for example, by default. So what we need to do is to actually go to extensions and available, load from. Now we search for LyCO. install, and it will become available. We can restart Stable Diffusion, and we will be able to use LyCO. Now, when it comes to LyCO, instead of LoRa, we have to put LyCO, LyCORIS. Okay, then we write the model name and the weight. Now, this is how we use LyCORIS. So now we can compare the scenarios. We want to compare from epoch 2 till epoch 8, for example. I don't want to include epoch 1 because it's usually not very good. So we start with epoch 2. We put the LoRa, epoch 2 till epoch 8. Now this will be like the row. Now the row will then be replaced by columns. These columns would be the name of the model itself. Because I'm using LoRa and LyCO, I will use the Y. In the Y, I'll put LyCO. Okay. Then I will include all the models that I have developed. Now I have generated a couple of grids, XYZ grids. Now here, okay, don't be deceived by the title, the caption here, because here in each of these captions will be replaced by these. Okay, so this represents basically the epochs. Some I tested from 2 to 6, 2 to 7, 2 to 8. And here are different models. Some of them are different than others, some with regularization, some without. Now, initially, for example, for portraits, we can see that having no captions can mess up the image. Okay, sometimes we get acceptable images, otherwise we don't. Okay, having no regularization could actually sometimes produce better results than having regularization for portraits based on these initial results. Okay, now this is LyCO without regularization. This is LyCORIS with regularization. Okay, they both look good here up till this epoch, but later we can see that the LyCO is better. In general, it's difficult to say which is better. They both look acceptable. In general, they resemble the subject. Okay, this is without regularization for the standard LoRa, and this is the standard LoRa with regularization. So the features are there, but the resemblance, there are some artifacts in this example here. Here we see that without regularization we have less artifacts. Now another portrait test. In this portrait test we included more examples. Now what I have added in this test is this section. This section is LyCORIS but with less alpha. Now with less alpha starts to learn much more slowly, but we can see that the features are there. So the eyebrows, the eyes, the nose, the lips, etc. Okay, this is a very good example. On the other hand, we can see that here the image starts breaking very quickly. Now the LyCORIS seems to be to have more details in general, and without captioning, without regularization, the results it's giving us some good results even without regularization. So it's also difficult to say which is better in general, this one or that. If we move to another example, we see the same conclusion basically. It's really difficult to say which is better. Now, in general, it seems that the LyCORIS is producing finer results in general, but not all the time. For example, here, without regularization, it's producing good results in standard LoRa. Now, if we try to change the hairstyle, for example, we can see changing the hairstyle does not produce very good results in most of the models. Now, the best model seems down here. Okay, this LyCORIS example with the regularization is still learning because it's clearly that it's improving but has not reached the target that we want. Now, on the other hand, this one without regularization, it has improved enough. But if we see that we have blonde hair, but it brought also the eyes, sure. So now we have blue eyes, but I did not ask for blue eyes. So this is a problem. If I bring other features, we might get something that we have not specified. If we go to the original dataset, you can see that this is more like this picture, for example. But the eyes here are brown. Here they have become blue. Okay. Now, if we go to another example here, okay, we can see that giving these pictures, I would say that this row is the best. This is LyCORIS as well. LyCORIS with smaller alpha. Now, this is LyCORIS with higher alpha. Okay, this is alpha 16. This is alpha 8. This is convolution of dimension 8. This is convolution dimension 4. I would say that lowering alpha would produce better results. The transition is smooth, is happening, and it's still learning. So the picture is still improving. We could also come here and try to see that this picture actually resembles this one to some extent. It has even preserved the eye. It has changed the hairstyle a little bit to become blonde. The skin has become whiter or like blonde. So this picture looks like this one. So I would say that LyCORIS with regularization is more flexible than LyCORIS without regularization. So regularization allows us to change hairstyles and it still preserves the color of the eye. I would say that LyCORIS with regularization is slightly better. Now, when we come to full body shots, they are not good in general because I use a little small amount of data. Now, this is without captioning. So I would say that without a doubt that having a caption is very important. Okay. Now, these results, if we come to some of these, for example, this is LyCORIS with regularization, okay, and a lower alpha. Now, with higher alpha, we can see that the training is not really good. The results are not that good, okay? They are acceptable in the first few epochs, but they start breaking very quickly. On the other hand, we can see here that at epoch 6 and 7, the results are still improving, okay? Now, on the other hand, without regularization, we can see that the subject resembles our subject less. So I would say that regularization can improve the flexibility. Now, this is another example here. We can see that the body is broken without captions, so captioning is very important once again. If we come to an example here, okay, in this example, we can see that the picture no longer resembles the subject. Okay, this is like another person completely. So this is LyCORIS without regularization. If I go up, for example, this is LyCORIS with regularization. So despite that it does not resemble the subject so much, but it's still way much better than this one. This is considered acceptable. Okay, now I would say that LyCORIS with regularization can produce better results with the new clothes, new body poses, new hairstyles, etc. Now this is an example. This is another example here as well. Okay, we can see here. Now in this here, this is LyCORIS regularized with smaller alpha. It's acceptable in general. Now this is higher alpha. It's not really good, none of them. Now LyCORIS with lower alpha is better. Now this is Standard LoRA. None of them is really that good. Now this is without regularization. This is with regularization. LyCORIS is producing better results. Now this is LyCORIS without regularization. The pictures are not like the subject that much. These look more like it. Now this is full body shot. Now this is here we have a very important note. Now this is LyCORIS without regularization, and this is with regularization and smaller alpha. Now what we see here is that this looks much smoother, and actually this is how the picture looks like in the training dataset. If we come here, we can see that this is more like this one. Now in my dataset, the face does not appear very well, so LoRa will not be able to train on it properly. So if I want to improve these results, I would have to include a 1024 full body shots in order to have better results. So having a lower resolution is not helping. Okay, we need better resolution in order to improve the results. So this is what I conclude. As I conclude also that without regularization, it's actually learning all of the body. Okay, so it's learning the entire body. Now with regularization, it's actually figuring out that this is a face, this is a body, etc. But this is not the body in my dataset. So it's using another body and trying to attach the face to the body with high resolution fix. I would say based on this, despite that it's not look like our data, if we trained more, we might get better results. I would say that with regularization, the model is more flexible because it's now able to attach the face to another body. Okay, its diffuse is not really good in terms of features, but it's actually learning new clothes and new different new body types. Okay, this is a new body. This body is not in my dataset, for example. So this is my analysis of the difference between this one. Now, while this looks slightly better than this one, this looks actually more flexible. So with the regularization, we could have more flexibility. Once again here, we can see that here it's learning the entire body. It's without regularization, it's really acceptable, while here it's trying to attach the face to a new body. Okay, so it's attaching the face to a new body. So the picture is not really good, but there's a potential to improve it with better data set, with finer training, with more training. So this is the conclusion about, this is the comparison between the various images from portraits to full body. So the conclusion from all of this, I would say that regularization does not always improve the results. However, they increase the flexibility. Okay, so if we are seeking to change, for example, the hair color, regularization is a better option. If we are thinking about changing the eye color, the clothes, the body type, etc., regularization will give us a better chance at doing this. Okay, while without regularization, it's more likely that we will be able to obtain more resemblance to the body, but it will be less flexible. Okay, so we should ideally train both regularized set and without regularization and compare which is better for our use case. And have a good day.